Hello, grade 11s. Welcome back again. We are doing trigonometry reduction formulae today. We've been working on this trigonometry, and it's such an interesting chapter, and it's the easiest of them all. This is where we should be capturing all the marks. Everyone should be getting full marks for trigonometry. All right. So today, as we will be busy doing the reduction formulae, please be reminded that your sine theta is opposite over hypotenuse, your cos is adjacent over hypotenuse, and your tan is opposite over adjacent. And then now, talking about your cast diagram, we're looking at all four quadrants in grade 11. And we have 0 degrees and 360 here. And then we've got 90, and then 180 degrees, and then we have 270 there. Now, guys, if you look, this is your first quadrant, this is your second quadrant, and that's your third quadrant, and this is your fourth quadrant. And we've got our cast diagram. Now, if we look in your first quadrant, guys, where you have A, and then what does this A represent? It represents that all the trig ratios are positive in the first quadrant. So if you are falling onto the first quadrant, your sine is positive, your cos is positive, and your tan is positive, together with the reciprocals, your cosec, sec, and cot. But when it comes to the second quadrant, you have sine, which is positive, and also its reciprocal. And then in the third quadrant, we have t, which is our tan, that is positive in the third quadrant, so it means that the rest will be negative. And then in the fourth quadrant, we've got cos, that is positive in our fourth quadrant. So in other words, if I fall into the fourth quadrant and I'm given sine, I check first, okay, that quadrant, it's where cos is positive, so it means that the rest is negative, okay? Right. Now, let's just take an example here. Let's assume you're given sine of 180 degrees plus theta. All right. Now, 180 degrees is a direction. Where are we? Right? So you've got sine of 180 plus. So that is the third quadrant. How is sine in the third quadrant? It is negative because that's where tan is positive. So if you look, this is sine of, it's negative sine of theta. Now, let's just check with our calculator. If I give you sine of 210, you see, this is 180 degrees plus an angle, which gives us our solution is negative. Now, let's try another example. Let's say we have cos of 261. Now, where is 261? Right? It's between 180 degrees and 270, and that is the third quadrant. We are expecting an answer of a negative, so because it is the third quadrant and tan is the one that's positive. So you see. Now let's see if maybe we've got cos. Let's try in this quadrant, in the fourth quadrant. Let's take cos 330. Right. Now, guys, watch. What sort of answer are you expecting there? 330 is between 270 and 360. And according to our cast diagram, in the fourth quadrant, that's where cos is positive. And we're given cos there. So that's cos 330, which is your cos of 360 minus 30. So our answer should be a positive answer. Cos of 330 is the square root of 3 all over 2. So you can check with your calculator if your answer is correct or not. All right. Now, we will also be looking at your co-ratios, and then the co-ratio of sine is cosine, and the co-ratio of cosine is sine. Now, if I've got the 90 and the 270, you'll see when you're working with the examples, the 90 plus the 90 minus is going to change the nature of your trig ratio that is given at that particular time. Now, let's just check with a few examples. Let's say you've got cos of 30 degrees and then sine of 60 degrees. Okay, so now we can quickly go to our calculator. That's cos of 30. This gives us root 3 over 2. Okay, so that's root 3 over 2. Now, let's check sine of 60, right? That is root 3 over 2. Now, guys, let's just establish what has happened here. Okay? I've got cos 30. Cos 30, this will be your cos of 90 degrees minus 60. And then we check 90 degrees minus is the first quadrant. How is cos in the first quadrant? It is positive, but because of 90, your cos will change to sine. So cos of 30 will be equivalent to sine of 60 degrees. So in other words, if I've got sine of 10, it will be exactly the same as your cos of 80, all right? And so on and so on. All right, so now if you look, going back to our cos diagram, as we were saying, this is 0 degrees and 360, 90 degrees, 180 degrees, and then your 270. Now, in the first quadrant, I can have 0, 1, 2, 3, 4, 5, 6, up to 90 degrees, all right? So, it is 0 degrees, or 0 plus an angle, right? So it's more than 0, but less than 90 degrees and 90 degrees minus. So we're expecting to be getting degrees like 1, 0, 25, 37, 86, and so forth, so in your first quadrant. But then when we come to the second quadrant, as you can see, it's between 90 and 180. So that's 91, 92, 93, up to 180 degrees. So we have in the second quadrant, it's 90 degrees plus or 180 degrees minus. And then in the third quadrant, you've got your 181, 182, up to 270. So it's going to be 180 plus or 270 degrees minus an angle. Same thing applies with the fourth quadrant. You've got 270 plus and 360 degrees minus. And mind you, with the positive and the negative angles, so if it's a plus, we are in the first quadrant, and then if it's a minus, we're moving that direction. Okay. Right. Now, some of the things that we're going to be talking about, it's your special angles, right? So the special angles that we'll be talking about is your 30, your 45, and your 60, all right? So back in the day, we used to have a triangle like this, whereby you've got a 1, and the square root of 2, working it from your Pythagoras, okay? Then with the special angles, when you are working with 45, so say for instance, you need to know what is sine 45 equals to. You know that sine is opposite over hypotenuse, so that's going to be 1 over the square root of 2, or you can just rationalize the denominator, and then you get the root 2 all over 2. Same thing applies to cos. Cos 45 is 1 over root 2, or the square root of 2 over 2. Okay. But now the tan of 45, remember, tan is y over x, so that is 1 over 1, which gives us a 1. So these, at any given time, you can be asked to, you're simplifying a problem when it gets to the special angles. There's no need to go to your calculator, guys, because you can learn this thing. And I advise that you guys make sure that you know your special angles by heart, because when you're busy, you're taking the Olympiad questions, you don't need to use a calculator, so you have to know them by heart. Okay. And then we come to the 60 and the 30. Remember, guys, this is 30. Man, what am I doing? Okay, so this is 30. All right, to complete that triangle, 90 plus 60 plus the unknown equals to 180. All right, so now if you take the triangle, the 60, right? Now, if you want to work out what sine 60 is, you know that sine is opposite over hypotenuse. So opposite in this case is your root 3, hypotenuse is 2, okay? And then if you're working out cos of 60, that is your adjacent, cos of 60 will be adjacent over hypotenuse, which is a half, and then your tan of 60 is opposite over adjacent, so that's square root of 3 over 1. Okay, all right. Now, moving on, let's take the 31, right? So now, with 30 degrees, you can turn around your triangle so that you can be able to see which one is adjacent, because if it's sitting like this, some of us are getting confused and we're thinking this is the opposite, where else we said the opposite is the one that's directly opposite the angle. So for 30, opposite is 1, the adjacent is the square root of 3. Okay, right. Now let's work out sine 60 sine 30 degrees is, now we know that sine is opposite over hypotenuse, so the opposite is 1, so that's half, and then cos of 30 is adjacent over hypotenuse, and then tan of 30 degrees will be opposite over adjacent, which is 1 over root 3. And then you can rationalize your denominator by multiplying by the square root 3 over 3, which gives us the root 3 all over 3. Now, there's something interesting here, guys. If you look, sine of 30, right? Sine of 30 is a half, which is exactly the same as your cos of 60. Now, see what happens. There's a 30, there's a 60. So the co-ratios, you see, sine of 30 is sine of 90 degrees minus 60, all right? 90 minus first quadrant, but because of 90, sine will have to change to cos. Now, if you look at your cos of 30, it is equivalent to your sine of 60, and then we get the square root 3 over 2 for both. Okay. Right. Guys, you'll take this example quickly, right? Reduce the following expression to a trigonometric ratio of theta, right? So I'm giving you just a minute to work on this problem, and then we'll look at it together. Right, let's go. Grade 11, you've got your sine of 180 degrees plus. First of all, we need to establish which quadrant is 180 plus. Now remember, if you look at your CAS diagram, this is 0 plus 90 minus 90 plus 180 minus, then this is where we have 180 plus. So it is in the third quadrant, and if you look at your CAS diagram, all students take coffee, so T is the one that's positive, so it means that we've got a negative sine of theta. Right. Guys, just work on some problems for now. You've got your books and whatnot, but just go quickly, grab some water, and then you'll come back after break and we'll continue with some nice trigonometry. Let's go for break.